Oh, is it recording now?
Yes, there you go.
Okay. All right. So we are recording. Good morning, everyone. I'm Dr. Raful, if in case you don't know me. And welcome to the course called Math 532, Difference Equations and Applications. This is a textbook that we will be using. There's a syllabus on the syllabus page, on the syllabus tab on Canvas. And there's a syllabus and with the book name listed on it. And as you can see, I'm the author of the book. It's published by Academic Press. Came out about 7 months ago, the book. So it's brand new. Is it available in the bookstore? Did anybody try? I guess not. You need the book. Anybody got the book? You can answer yes or no. Has anyone got the book?
I haven't
Can
got
we
it
get it
yet.
online, like a digital copy?
I don't know if they have digital copy. I don't think they do. Did you check? I don't think there's a digital copy. And so I will be following my own book, okay? The homework problems are 100% from the book. I have already assigned homework 1. It's due on Thursday midnight, okay? You need to go to Canvas. You need to log into Canvas and see all the information there. So there is a homework 1, section number, page, and problems you need to turn in by Thursday at midnight. I want you to work in a group. Let's form 3 groups. I'm not gonna say whose group is what it consists of. So you figure it out on your own. And when you turn in your homework, put all the group's name on the first page of the homework, okay? And the homework should be turned in online under homework 1. You can upload your homework there. Is that clear? Do not email me your homework. Upload them. I think the best way to do is to scan them and upload them on Canvas under homework 1. As you know, already we talked about it. We are recording the class. So at the end of the lectures, as soon as I get the recording back, I am going to do 2 things. I'm gonna upload it to Canvas under files. Okay, I created Math 532, and I will upload my video there. I will call it video 1, video 2, video 3, and so forth. Okay, and I am going to upload them on my YouTube channel too. The reason is I want to do YouTube because Canvas will delete all the videos in 1 year. So I want my lecture to be out there in case I need to resort to them sometimes in the future. So I could. And so you can have access to the recording in 2 different places, on Canvas under files, or on YouTube under my channel, and it's public. You don't need to sign in. Okay, I will do my best to do it right away after the class and see how things work. So you need to form 3 groups. Okay, so I said 3 groups, right? So one group will have to have 3 because there are 11 students. All right, any question for me? Any questions? Okay, so how many people do we have here? We have 11 participants, so that's the whole class. All right, and again, we are recording. All right, if you don't have any questions, and I told you what's the book we're gonna use, so So anyway, so this book, we're gonna study, it's called difference equations. I mean, you are used to differential equations. This is over the real numbers and this one is over the set of integers. Okay, so this is the difference between the two. So basically, we want to study the qualitative behavior of sequences of the form, say, x1, x2, x3, xn, and so forth. Okay? So we're going to study the behavior of them as n goes to infinity or what happened. All right. So how is the quality? How can you see the board? Can you see it okay?
Yeah, it's good.
All right. All right. So this is the difference between, I will make remarks as I go regarding the difference between the difference equation and the differential equation, so you can see the analog between the two. Okay? Because they are usually, I mean, the only one is on a set of integers and the other one is on a set of the real numbers. All right. So with that being said, so let's say we have x1, x2, x3, xn, and so forth. So we're gonna put del x2, del x1, for example, is x2 minus x1. So the difference between two consecutive numbers. And then this is called, for example, del x2 is x3 minus x2. So del x1 is x2 minus x1, x3 minus x2, and so forth. If you go for del xn, that will be xn plus 1 minus xn. So this is the difference between two consecutive numbers. The forward difference between two consecutive numbers. Okay? The forward difference means the preceding one minus the previous one. Okay? Or the current number minus the previous number. So that is the difference. So this is called, so the delta is called the difference between two consecutive numbers. All right? And so this is the general case. All right? Now I need you to read the introduction of the chapters because I talk about different set of numbers, so you need to be familiar with them. Okay? For example, this set n0, or may I say n of n0, is the set of n0 and 0 plus 1 and 0 plus 2 and so forth. Okay? And where is n0? N0 belong to the z, and z equal to the set of all integers, the set of all integers. Okay? It could be negative, but we usually take n0 to be positive, to be bigger or equal to 0, or we take it to be 0 most of the time, and so forth. Okay? Now, so here we looked at the jump. The jump is 1 because I go from x2 minus x1. I usually, if I do something like del xn equal xn plus h minus xn. So this is the jump here is h, and h is belong to z plus. It's a positive number. But in this course, we take h to be 1. So that is, we are using del xn to be xn plus 1 minus xn. Okay? So the jump is 1. So it's the number minus its preceding one immediately. Okay? Is that clear? All right. Recall in differential equation or in calculus, x prime of t is the limit as h approaches 0, xt plus h minus xt over h. That is the derivative, right? This is the instantaneous rate of change of the function x at t. Let me repeat, this is the instantaneous rate of change of x at t, and it's called x prime of t. Now, if I take h equal 1 and t is n, then I'll have x prime, if you like, is xn plus 1 minus xn. So instead of saying a prime, we will say del xn is xn plus 1 minus xn. You see that? If I take h equal 1, then I'll have this one because the jump is 1. In differential calculus, h can be as small as you want. And you notice you're taking the limit as h goes to 0. By the way, for those who never had me before, instead of writing LIM, I will just go like this, okay? That represents the limit, okay? All right, any questions? Okay? So let me make the first definition. Let me know if I am going too fast so you're not keeping up with the note. I can slow down a little bit or give you more time to copy things down. Now, remember, yes, on my Google Calendar, I had the invite for every day of the week, including Saturday, Sunday. This is not the case. I just was lazy when I did that. I just didn't want to go Monday through Thursday. So we meet Monday, Tuesday, Wednesday, and Thursday. So we have a Friday off of every week. Okay? And I believe 4th of July this year is on Thursday. So we do not have a class on Thursday. All right? Okay. So we have a definition. Let xn be a sequence. Okay. And x go from Z into R. Okay. Then the delta difference operator denoted by triangle is defined as del xn equal to xn plus 1 minus xn. Okay? Now, on the other hand, the shift operator E is defined as EXN equal to XN plus 1. Okay? So this is the shift. You only shift XN by 1 because here our shift is 1, not H. So hence, del xn can be written as xn plus 1 minus xn. That is EXN minus xn. Okay? Any questions? So why is difference equation important? It's important in numerical analysis because in numerical analysis, sometimes you want to do numerical solution. So on a continuous interval, the computer will crash. So you take the solution at an interval at like x1, x2, x3, x4, x5, and you want to study the solution, how it behaves on those intervals or on those points. Hopefully you take enough of them to have an idea how the solution behaves. Okay? All right. So for example, if you have xn is 2 to power n, then EXN equal E of 2n is 2n plus 1. You see that? And del xn is 2 to power n plus 1 minus 2 to power n. Okay? And that is 2 to power n will be 2 minus 1, and that is 2 to power n. And that is xn. So this is only one where the difference is the sequence itself. Okay? Any questions? For example, what is del square of xn? It's like the second derivative. So that is del of del xn, and that is del of xn plus 1 minus xn. Treat this as one sequence. So that is going to be x of n plus 1 minus xn plus 1 minus xn plus 1 minus xn. You see that? And so this is xn plus 2 minus xn plus 1 minus xn plus 1 plus xn. Okay? So that is equal to xn plus 2 minus 2xn plus 1 plus xn. Okay? So for example, del square of 2 to power n is 2 to power n plus 2 minus 2 times 2 to power n plus 1 plus 2 to power n. Okay? And that is 2 to power n, right? Why? Because this one and this one wave goodbye. They cancel out. So you are left with 2 to power n. So this is like this is similar to xt equal e to the t. What is x prime of t? Is e to the p. What is the second derivative? That is e to the t. Okay? In the continuous case. All right? Any questions? Now, definition, the order of a difference equation is the difference between the highest argument minus the lowest argument. Okay, I will do a couple examples to show you what's going on. Again, a general first order difference equation can be put in the general form xn plus 1 equals some function fn xn. Okay? And I will give you an example in a second. All right. So I'll let you copy down. You're all caught up? Okay. for example, xn plus 1 minus 3 x squared of n plus 2n equal 5. So this can be written as xn plus 1 equal to 3x squared of n minus 2n plus 5, and this is fn xn, where fn xn is 3x squared of n minus 2n plus 5. Okay? You see that? So what is the order? The order is, this is the highest, n plus 1 minus the lowest, n, and that is 1. So this is first order difference equation. Okay? So the order is 1. All right? What about if I have xn plus 4 minus 3x squared of n plus 3 plus 1 plus 2n equal 5. So the order is n plus 4 minus n plus 1, and this is n plus 4 minus n minus 1, and that is 3. So the order of this difference equation is 3. Okay? But this can be written as xn plus so if I let k equal n plus 3, so this can be written as x of k plus 1 minus the 3x squared of n plus 1 k minus 2. Okay? You see that? And plus 2n plus 2k minus 3 equal 5. So xk plus 1 equal to 3x squared k minus 2 minus 2k minus 3 plus 5. So this will be f of k xk. So you can always put it as xk plus 1 equal. But you see here you have a negative argument, and we really have not talked about it, or that's okay for now. Okay? All right. Okay. Let's see what's next. So xn plus 1 equal fn xn is said to be linear if, when substituted, xn equals cyn, we get yn plus 1 equal f of n yn. Okay? So basically, if you have xn plus 1 equal 5xn, 5xn, basically, let's put it this way. Then, so this is fn xn, and if I let xn equals cyn, then f of n xn equal to 5cyn, and that is 5. You see, this is a c minus 5yn. So we have cyn equals c times 5yn. We have cyn plus 1, sorry. So we have yn plus 1 equal 5yn. So it is linear. Okay? So the definition means what? So the definition means if you replace fn by 5 by cyn, you will get c f of nyn. This is what you should get. This is what you should get in order for it to be linear. And look at the easiest one, xn plus 1 equal 5 xn plus 1. Look, so we have fn xn equal 5 xn plus 1, and so f of n cyn equal to 5 cyn plus 1. This is equal 5 c 5yn plus 1. That is different from c fnyn, so not linear. So this is not linear. Just because we added 1, it's not linear. Okay? Another thing, if I have xn plus 1 equals sine xn plus sine yn, that's it. So if I replace, so we have f of n xn equals sine xn, and so fn cyn equals sine cyn. That is different from c sine yn, so not linear. Okay, not linear again. All right. So these are some examples of linear, non-linear. All right. Let's say definition. We say phi n is a solution of xn plus 1 equal fn xn if phi n plus 1 equal fn phi n. So this is what it means for something to be a solution. Okay. I'm just looking at my note to give you an example here. If you can see that you can see, for example, yn plus 2 minus yn plus 1 squared plus yn squared equal minus 1. Can anybody tell me whether this has a solution or not? What do you think? What is this one here? Is that positive or negative? That's positive, correct? What about this one? Positive. So you cannot find a function, so you square it and plus another square, you get negative number, correct? Okay. So the question, this has no solution. Has no solution. Okay. All right. So by the way, the book has a partial solution manual that is available to you. If you, I don't know how the publisher give you access to the solution manual. I think if you buy the book, they give you the URL or something. And I made the solution manual. It's partial, but I try to do as many exercises as possible. All right. So let's say, show that xn equals c plus 2n plus 1 solves xn plus 2 minus 3 xn plus 1. No, sorry. I was reading this, the different one. Solves xn minus xn minus 1 equal 2 to the n. So what is xn minus 1? Xn minus 1 is c plus 2 to the n minus 1 plus 1, that is c plus 2 to the n. So xn minus 1 is c plus 2 to power n plus 1 minus c minus 2 to power n. Okay? C minus c go away. So this is 2 to power n plus 1 minus 2 to power n. Factor 2 to power n out, you get 2 minus 1, and that is 2 to power n. So that is a solution, okay? All right. Any questions so far? All right. So now we're gonna move on to section 1.2. Any questions so far, guys?
No, we're good.
Eh?
I don't. I think we're good. You can
All right.
proceed.
Good. All right. So let's.
I actually had a quick question about the solution.
This one.
Just more of a in general question. So you said that it has a solution if 5n is the solution of it if 5n plus 1 is equal to f of n. So basically, as long as when you plug in your new equation into the previous one, and you get something that makes sense, it's a solution. Kind
Yeah,
of like
you get a true statement.
okay.
Like for example, here I substituted in the left-hand side, correct?
Yes.
So I substituted in the left-hand side. In order for this to be indeed a solution, what should I get? 2 to power n, right? What did I get when I replaced c plus 2 to power n plus 1 in the left-hand side?
Oh, okay. I see now.
Look what I got. I got 2 to the n, the right-hand side, okay? All right? So you have a true statement, something that makes sense, okay? All right. All right. Now we're going to talk about something you've seen before, and we're going to call the gamma function. The gamma function. So the gamma function, we denote the gamma function by this one and is defined by gamma of z equals 0 to infinity e to the minus t, t to the z minus 1 dt, and this is the real of z is positive. So that is a gamma function. Okay? So we claim gamma of z minus 1 is, sorry, gamma of z, may I say, is z minus 1 gamma of z minus 1. Okay? All right. So the proof of the claim, when I put a PF, mean the proof. So it's integration by part. Integration by parts. So we're gonna let dv equal e to the minus t dt, and u is t to power z minus 1. You see that? Then du is z minus 1 t z minus 2 dt, and v is minus e to the minus t. So you integrate by part now. You okay with that? So you know the integration by parts is u dv is uv minus v du, right? Okay, so let me get this here. So gamma of z is 0 to infinity e to the minus t z minus 1 dt, and that is minus e to the minus t u times v from t equals 0 to infinity plus 0 to infinity e to the minus t z minus 1 t z minus 2 dt. Okay, so when you integrate, this is what you're gonna get. It's uv minus v du. That is the u and that is the v, and minus times minus, you get a plus, and this one. So this is 0 because e to the minus t dominate. E to the minus t dominate. So that's why this is 0. So you are left with, you see, the integration is taking with respect to t. And on the inside, I have z minus 1 as a multiplying factor. So I can pull it out. So I get z minus 1, 0 to infinity, e to the minus t, t z minus 2 dt. Well, take a look at the definition. Take a look at this definition. What if I replace z by z minus 1? What would I get? Is 0 to infinity e to the minus t, t z minus 1 dt. So I get 0 to infinity e to the minus t, t z minus 2 dt. So this one I just showed you, that is tau z minus 1. So that is z minus 1 tau gamma z minus 1. Okay? This is what it is. This one is this one. Okay? I am not dividing. I'm just telling you this one is this. So don't, please, I am not dividing here. In my calculus class, they would think I'm dividing. So all I'm saying, this is gamma of z minus 1. That's all I'm saying. Okay? So that's a proof, this one. Any questions so far? So is everybody in Dayton or some people are overseas? You can answer. For a future reference, so we can, when we take a survey, we know how to fill it up. Do you have anybody overseas?
Yeah, I'm out of Dayton, but I'll be coming back soon. So I'm just like inside Ohio,
Okay.
but not in Dayton. Yeah.
All right. Okay. So that being on Zoom is of help, I assume. All right. So the gamma function has a lot of interesting property. I mean, I can give you a whole course on the gamma function, but this is not the purpose of this class. Okay. So if we replace z, if we replace z by z plus 1, then what do we have? You see, we showed this equal to that. Then we get gamma of z plus 1 equal to z plus 1 minus 1 gamma of Oh, sorry. Yeah, gamma of z, gamma of z. Okay? So that is z gamma of z. All right? All right? Now, so we showed that gamma of z equals z minus 1, gamma of z minus 1. So if z equal n is a positive integer, then gamma of n is n minus 1, gamma of n minus 1, and then gamma of n minus 1, and if you go all the way, so this is gonna be n minus 1 factorial. So gamma of n is n minus 1 factorial. Okay? And gamma of n plus 1 is n factorial. Okay? Now, as I said, there are tons of formula derived from the gamma function. And there are tons of them all out there, so I cannot cover all of them. But some of these formulas are important for our derivation. That's why I am doing. Okay? And then it can be shown that gamma of n over 2 is gamma of 1/2 times n. And this is when n is factorial. And this is n minus 2 factorial factorial over 2 raised to power n minus 1 over 2. And this is times the square root of pi. And this is double factorial. Okay? And so if n equal 1, then gamma of 1/2 is, okay, is n minus 2. So gamma of 1/2 equal to square root of pi. Gamma of 3.5 equal to square root of pi divided by 2. All those you may need later. And gamma of 5/2 is 3 the square root of pi divided by 4. So here I took okay. So we are assuming for n minus 2, we're assuming that the factorial of negative number is basically 1. It's like the factorial of 0 is 1. And so here I took n equal to 3. If you take n equal to 3, you get sigma of 3.5. So it will be 3 minus 2 will be 1. So this is 1 over 2 times the square root of pi. So you see how you get it? Put n equal to 3. You get a 3 minus 2. That is 1. Factorial is 1. Factorial is 1 over 2 minus 1. 3 minus 1 over 2. 3 minus 1 is 2. 2 over 2 is 1. 2 to power 1 is 2 times the square root of pi. You see that? And the same thing, if n equal 5, that will be 3 factorial. And then you can simplify it and get the 3 square root of pi. It's not the 3 times, it's times 3 over 4. Okay? All right. All right, so now let's talk about the factorial function. Factorial function, and this is t to power r. You see how it's written? Okay? So it's defined by t to power r is t times t minus 1, t minus r minus 1 for r in n, which is 1, 2, 3, and so forth. This is a set of natural numbers. And 0, actually, it's supposed to be 1. If r equal to 0, and it is 1 over t plus 1, t plus 2, t minus r, and this is for r belong to minus n, which is minus 1, minus 2, minus 3, and so forth. And it is the gamma function of t plus 1 over gamma of t minus r plus 1 if r is not an integer. So if r is not an integer, okay? All right. Any questions? This is t plus 1, looks like a d. T plus 2, all the way down to t minus r. Okay, so for example, t to power 1, t, that is t to power 1, and that is t. Okay, because if you put t minus r minus 1, you will get 0. So you better stop here. So you have one term. So you see what I mean? If you have t squared, that is, so if you put it here, will be t minus r minus 2 will be t minus 1. So you only have t times t minus 1. T times t minus 1. You see that? So this is a notation that you and I agreed on today. Okay? So if you want t cubed, that is t t minus 1, t minus 2, because if you put r 3 minus 1, you will get t minus 2. So you get t minus 1, t minus 2, and you stop. Okay? And so forth. Any questions? So what is 1 to power r if r equal to 1, 2, and so forth? So if r equal 1, that is, so you are looking at this here. So it's gonna be whatever. It's gonna be 1 times 1 minus 1 times 1 minus 2. So automatically this is 0. So 1 to power r, for r being 1, 2, 3, and so forth. So let me rewrite it again. So we know t to power r is t minus 1, t minus 2, t minus r minus 1 for r equal to 1, 2, 3, and so forth. So if I have 1 to power r for any r is 1, 2, 3, immediately I have 1 times 1 minus 1. So for r equal 1, that will be 0. Okay? So this is for r equal 1. For 1 to power r is, let's say r equal to 2. 2 will be 1 times 1 times 1 minus 1 immediately times 1 minus 2, and that is 0. Okay? So for any r equal 1, 2, 3, 4 all the way, you will always get 0. Okay? All right. So for example, what is 2 to power 1? Is 2, that's it. 2 to power 1 is 2. What is 2 to power 2? That is 2 times 2 minus 1. So that is 2. Okay? What is okay? So, and then you can go so far. So let's do one with exponential. Was what is 5.5 to power minus 3.5? 5.5 to power 3 minus 3.5. Which one? That will be this one, correct? Because r is not an integer. I don't care about t. So we're gonna use sigma t plus 1. So this is sigma t plus 1 over sigma of t minus r plus 1. All right. So that is going to be sigma of t plus 1. T is 5/2. Sigma of 5/2 plus 1 over sigma of 5/2 minus r. But r is minus 3.5 plus 3.5 plus 1. Okay? And let's see what this is actually. This is sigma of 7.5 divided by sigma of 5. Okay? Why is that? 5 plus 3 is 8 divided by 2 is 4 plus 1, sigma of 5. So that is sigma of 1/2 times 7 over sigma 5/2. You're going to have to use sigma of n over 2. Sigma of 1/2 times n. And here n is 7. So you will get 15 square root of pi divided by 8 over 4 factorial. Because sigma of 5, gamma of 5 is 4 factorial. And then that is 5 square root of pi divided by 6. Okay? And then you can do other examples. Any questions so far? Okay. Any questions? All right. So you will see why we introduce the factorial function. All right. So example 1.8. I have been doing examples from the book, but I have not labeled them yet for you. Okay. So, but this one, I will say, so it says express t cubed as a linear combination, as a linear combination of t cubed, t squared, and t. Okay. So look, t cubed is t minus 1 times t minus 2, correct? So there is 1 t cubed term, correct? What do you think? Okay. What about t squared? t squared is t minus 1. No t cubed term. And t is basically t. Again, no t cubed term. Well, here there are more than one t squared term and t term. Okay, so we say t cubed is t cubed plus alpha t squared plus beta t. Why? Because there are more than one term t squared. There are more than t squared term and more than one t term. Okay? So I just need you to understand that. And now what we're gonna do is we're gonna expand these terms. Okay? So this is t times t minus 1 times t minus 2 plus alpha t times t minus 1 plus beta t. Okay? So I need to find alpha and beta. Okay? I need to find alpha and beta. All right, so this is t squared minus t times t minus 2 plus alpha t squared minus alpha t plus beta t. Okay? I'm gonna flip my board, but I'm gonna recopy this with me. So far, I have t cubed equal to t squared minus t times t minus 2 plus alpha t times t minus 1 plus beta t, or alpha t squared minus alpha t. So that is t cubed minus 2t squared minus t cubed, no, minus t, okay, sorry. T cubed minus 2t squared minus t squared, sorry, plus 2t plus alpha t squared minus alpha t plus beta t. So that is t cubed plus, how many t squares I have? I have minus 3t squared plus alpha t squared, this and that. Okay? Plus 2t minus alpha t plus beta t. That is this, this, and this. So this is t cubed plus alpha minus 3t squared plus, okay, 2 minus alpha plus beta t. Okay? So this can be written as 0t plus 0t squared. Can't I? I can write this as this one. So look, t cubed is 1. So really what I have is, remember, this was t cubed, but that t cubed can be written as 0t plus 0t squared, a plus, without changing anything. So t cubed is t cubed, this with this, so I have alpha minus 3 equals 0, and this one is with this one, and 2 minus alpha plus beta equals 0. So I have alpha equal 3. Okay? And what is beta? So I have 2 minus 3 plus beta equals 0, beta equal 1. Thus, t cubed is equal to t cubed plus, sorry, the other way around. Thus, t cubed is t cubed plus alpha t, 3t squared plus t. And we're done. Okay? Remember what the question was. The question was, express t cubed as a linear combination of this, that, and that. And I did. Look at that. Okay? Any questions? Let me go on for another 5 minutes, then I will stop. Does anybody have any questions? I don't want to keep you the whole hour and 40 minutes the first day. Any question about this? Recall the binomial coefficient binomial coefficient is denoted by ki, and it's like this. So this means, and this reads as k choose I. So basically 0 less or equal to I less or equal to k. And so ki is k factorial over k minus I factorial, I factorial. Okay? And that can be written as k minus 1, k minus 2, k minus I plus 1 divided by I factorial. And because you have k minus I factorial, so they simplify. and this will give you k to the I over I factorial. Remember, this is our function. Okay? And this one is k to power I over gamma of I plus 1. Remember what I factorial is I plus 1. Okay? So these are the binomial coefficients. All right? And there are more about them that we're going to use later. And so I am going to stop here for today. We'll pick it up tomorrow and Wednesday. And let me see what I did with my pen. I really need you to get the book, okay? And there's a solution manuals. All the problems are in the book. They are already assigned. Does anybody has a does anybody has a computer in front of them? Can you log into Canvas for a second to the book, to the course website?
Yeah, I have checked the Canvas, and then also the book can be digitally accessed from the Canvas. So you have to rent the book and then you can access the book from the Canvas.
Or you can access the digital copy
Yeah.
from the library?
Yeah.
Okay, I did not know that. Okay, thank you. All right, so I am done for today. I'm gonna try to upload the video to 2 different places, on Canvas under Files. There's a tab for Files, and or on my YouTube account, so I can access them years from now. Any questions before I stop? Okay, you need to divide yourself into 4 groups, okay? So you do it on your own. All right, talk to you later.
Yeah, I have a question about the exam. So
Sure.
do you have any tentative date for the midterm exam?
I do. Are you asking me?
Yeah.
Expect something in 2 weeks.
Okay, all right.
All right.
All right, thank you.
Okay, and it will be take home. All right.
Okay, all right, thank you.
Okay. Anything else?
No, good.
All right. I'm gonna stop recording. Stop.